Dude, I was gonna say I listened to the daily today, but technically it's gonna be Thursday, so I'll have to say I listened to the
True,
daily on
dude.
Monday.
You listen to it on Tuesday
Or on yeah. Yeah, that's right, dude,
or
that's right.
Monday. Monday.
Monday. Yeah.
Monday.
Hidden threads begin to show. Speaking patterns break the code. Pre-trained pod.
And welcome back to the Pre-Train Pod, folks. My name's Richard.
And I Pierce.
Hey, Pierce. How you doing, buddy?
Hey, Richard. How you doing?
Good to see your face again, boss. All right, why are we here today? Let me tell you a little anecdote. So on Tuesday, my buddy sends me this. You know the New York Times Daily, the podcast?
Oh yeah, they do one a day, if I recall correctly.
I know, which is insane, by the way. But anyway, my buddy sends me this podcast from last Monday, and he's like, "Dude, you gotta listen to this. It's super important." And so I was like, "Okay." So I gave it a listen, and the podcast, I think the title was something along the lines of like, "Big Tech told kids to code, the jobs didn't follow," or something like this. And it was basically talking about how in the mid like 2010s, companies like Facebook and Google were pumping a lot of money into philanthropic organizations, nonprofits that try to get kids coding. And the promise was basically, look, kids, the future is in coding, and you need to be both literate in normal languages and also programmatic languages if you want to have a job in the future. Fundamentally, what is going to allow you to make the big bucks in the next 10, 20 years is your ability to code. And so there was a bunch of nonprofits that were started to enable children to basically learn how to code from a young age, to make it part of the school curricula. Companies were even, if I'm not mistaken here, trying to lobby government officials to incorporate coding as part of the core curricula of the United States, so that you could pick a language class, you could pick a science class, and you would also be able to pick coding, programming as part of your core curricula when you're in middle school.
I remember this era. It kind of coincided with the whole like one laptop per child push that people were trying to do, right?
Yeah, it was like a very futuristic, forward-facing era in our generation where I guess at this point we were probably out of middle school already, but it was sort of still within our generation where kids were really encouraged to start coding from a young age. And I think the viewpoint was that if we can just get more kids coding, we'll be able to create jobs and innovate in ways that will allow us to be competitive with countries like China and India into the future. Behind the scenes, the thing that wasn't said was that we need to catch up with other countries. And here in the United States, we need to really invest in STEM because this is the future, and these will provide also good jobs for the future workforce. And so, anyway, these programs were very successful, actually. So, a lot of people started coding. Fast forward 10 years from 2015 to 2025, we are now in a world in which the jobs with the highest unemployment are jobs that require coding. And it's, in fact, kids that are graduating this year and last year from universities with CS degrees that are facing some of the hardest times finding new jobs, entry-level jobs. And so this New York Times piece was basically talking about how these children have been lied to fundamentally. Like they were promised this future in which if they just learn how to code, start doing this from a young age, go to university, get a good degree, that they'll be able to work at a company like Google, like Meta, Amazon. And the reality is that maybe in part because they got unlucky, maybe in part because of the way that the global workforce has changed, it just so happens that right now is a really hard time to find an entry-level job. And one of the reasons is that people will talk a lot about is that AI fundamentally is the culprit here, in addition to things like the COVID pandemic, global workforce changes, and so on and so forth. But fundamentally, what I want to talk to you about today is, well, first of all, if coding is no longer the guaranteed path that I think it was promised to these children to be, what is the future of tech education? If you are a university bureaucrat who gets to decide the curricula of the CS degree, of different degrees, what are skills that you want to teach kids? How do you shape the CS education to set up children to be successful in the future? Let's talk about that first. And then I also want to talk about the latter point, which is, were these kids lied to? What role basically do big companies have when it comes to employing young CS graduates, and
Yeah.
to what extent were these kids lied to in the first place?
We'll go head to head with a daily.
Yeah, exactly. Because I do think that there are some things that we can maybe argue against or add some nuance to that the original podcast didn't mention, I think, to the full extent.
Yeah, 100%. I mean, I think that they took a very specific journalistic lens to this entire piece. And I think that it maybe missed some of the nuance of actually being in the industry and like seeing this evolution. But zooming out, I listened to this podcast and I was really struck by how they collapse computer science and computer engineering into the same thing. And on surface level, maybe those actually do, in fact, seem like the same thing, right? If you're graduating and you're a programmer, isn't that just the career path that those two things are going to funnel you into? And that's like kind of true, not. I remember Stanford made a pretty explicit point in being a computer science department instead of being a computer engineering department. And they actually didn't offer a computer engineering department as part of the university. And the remit there was that every class that is taught should have a scientific lens to it, almost as if you're pursuing computer science as an academic. You're doing research publications, you're trying to learn algorithms or come up with new algorithms in order to do novel things. It's not the rote skills of programming or getting like really good at doing large scale code base refactoring. Whereas some other programs are actually more oriented to that. I would say for us, programming was a necessary component of getting the job done, but they were actually trying to more teach us the theory, and the conduit was code, versus in a lot of other programs, and I think especially in these computer engineering departments, the point actually is the code and its output. And maybe they spend more time talking about unit tests and things that whenever I would ask profs, hey, you have these auto graders as part of these assignments that can score our code up to some standard. Do you want us to write unit tests for our own code? Are you ever going to teach us like some methodologies in order to create these? What's the philosophy? No one covered that, and no one was interested in covering it. These profs basically had the mentality of like test-driven design, like TDD. You'll go learn that in the real world. Take an internship or learn that post-college. The hard stuff, the real stuff that you're not going to learn once you get a real job, are the things that we're going to teach you. And I've actually found that to be relatively true, right? Like this fundamental base and this like really wide amount of things that are taught as part of CS programs, you'll obviously use some amount of that day to day. I have a hunch we actually probably use more than average people that are in CS by virtue of the fact that we also need linear algebra. We need to think about doing large scale distributed systems design. But for your average software, I'd say for the software that employs maybe 80% of the workforce, it's not that kind of stuff. It's like building some app that helps increase the efficiency of your company, some like internal tool, or like some software in the wild, which is like a pretty simple scope and then it expands over time. It's like different kinds of challenges. And I feel like in these niches, they're a lot more complex. So your question was around in a CS program, or what are the CS programs now and in the future? And I think that that's probably one thing for us to maybe think about. And then I think the CS community, the academic community, should probably spend more time thinking about is if the act of actually doing these jobs in practice is going to change and probably get a lot easier because AI is the thing that's writing a lot of this code. I would think that the theory of engineering and like the theory of distributed system design becomes that much more important. And maybe the code actually isn't really a part of the curriculum. Like maybe the answer in some of these classes is written textbook examinations, like you would do in an English class, where you say, here's the business problem, or here's the research endeavor that we have to do. Translate this into the questions you would ask and the distributed systems design, the algorithms that you would use, or the algorithms that you would create to do this, and literally no code. I could see us going that direction. I could also see us
treat the coding as like
hard.
a primitive. Yeah,
exactly. Much like these CS programs, you're covering the math that you need to know insofar as this is how you would do this tensor arithmetic. But for the most part, they kind of left the math up to the math department people. They're like, here are the Math 51 prereqs that you're going to need for this class. But for them, the Math 51 is a much broader scope. It's like a superset of all the stuff you're going to do in CS. They didn't really want to teach that. They're like, let's use this math as primitive. Yeah, maybe code even is going to become that primitive going forward.
Yeah, I think a lot of the foundations that you learn in a CS degree prepare you to debug code. I think that's pretty much all it is. When you're learning these foundations like linear algebra, like computation theory, like logic, All of those things fundamentally what they let you do is when you find yourself in a pickle, when you're writing code and you just don't know how to
As we do
solve a
from time to
problem.
time.
Hey, dude, we find ourselves in a jam all the time. But having those foundations is what lets you then start figuring out a process to get to the answer that you don't know to begin with, right? It's like saying if you're in a position where you feel helpless, like you really don't know how to even approach solving something, then the foundations that you learn in your education are what you can go back to begin to solve this issue. It's like, how do you figure out the unknown unknowns when you have a bug in your code? I think for those kinds of things, it's useful to have these foundations that let you say, okay, well, I don't know how I'm going to solve this, but I've seen these sorts of problems before in my probability theory course. And from those, I remember that in this set of scenario, you want to use this sort of a technique. Let me Google that. I think these foundations basically allow you to start to know what to chat or what to Google, and that those things are always going to be important. Like those things are always going to be evergreen. But when to force students to learn how to code something, that is a really delicate balance that I don't know how we need to solve. Do you want to force kids in college to implement MapReduce or like a thread pool? Is that something that we can treat as a primitive in the future? Or is that something that is part of these foundation tools that students need to understand how to program themselves? Is it good enough to just teach a kid, okay, well, this is how MapReduce works? Now you can ask Cursor to implement it for you, or these are the libraries that you can use. Or are those things so important that there are part of the foundations that you still have to learn how to code from scratch yourself? I think that these sorts of questions are really hard for administrators who are setting up these curricula to have to figure out for themselves.
Yeah. It's almost like a pedagogical question of how do people learn or how do they learn better than other methods? I always found that the act of implementing something was actually key for me to really understand how it worked. They could teach it. I could say, hey, I know this. And then this nuance of actually having to go through and set these variables and implement these arrays, that nuance actually led to much deeper understanding. Not because you're just coding, although that's part of it, right? These algorithms were meant for code. So I think if you've never even touched the code that's related to them, you won't understand some of the trade offs that were inherent to the algorithm because you're only seeing the algorithm as the end product. You're not really thinking through the decision tree in the middle of, well, like flash attention, right? If you just knew the math for doing attention, you would never even think to implement flash attention, or you would never understand why flash attention is so interesting because it gets to the lower level hardware of things. Like it's actually talking about CPU registers and how we put these things in different places. And I think unless you've touched that code, you might not actually grasp the full complexity of doing this. And you might think to yourself, okay, yeah, this is an implementation of this mathematical primitive, but it doesn't have to be the one. So I think that's a part of it is it helps you grapple through the different problems. But I think whether you could do that in a different way, if code itself necessarily has to be how you can get to those minutia in the middle, I think might be a little bit up for debate. You could maybe learn the same things by saying, let's take some existing implementation that someone already did and talk through the pros and cons and implementation considerations. I think that like is a plausible way to do it without you having to write the code yourself. I do probably lean on the side myself of what the code is and what it does is so inextricably tied together that just natural language to express some of these phenomenon probably is not enough. And you actually have to consider what it's doing. But that's also a very niche element of computer science. Like that's if you're trying to do research or if you're really trying to push the envelope forward on data models, you're going to have to know the specifics. For the bulk of the industry, if you're talking about employment aggregates, I imagine they were probably doing within a lot of these employment reports. Is that kind of knowledge required for you? Maybe not. One other thing to add to this too, Richard, is part of what people might be upset with here is it feels like some of the pitch of learning CS was doing that academically. This notion that, yes, we're baking it into the high school curriculum, middle school curriculum perhaps, but I still feel like there was this undercurrent of, and then you go to university. And then this is just setting you up to then go to college where you'll like really learn how to become a cracked coder. Do you feel like that maybe is what hamstrung this argument or has gotten people upset within this daily piece? It feels like people aren't really upset that we learned history or learned math in middle and high school, even if you don't end up having to use a ton of that day to day. I think people get a lot more upset when they just dropped 200 grand on some degree and now can't find a job, which maybe speaks to more vocational programs or some other form of doing computer science that's not the traditional academic path.
Yeah, I think people feel lied to, and that is why they're upset. What this daily article is trying to highlight is that a lot of kids felt like coding was the answer to getting a six-figure salary right out of the gate. And in part, the reason that they felt so is because a lot of companies would explicitly say, hey, take this boot camp and you will get a $150,000 salary at Google. Or if they weren't saying that explicitly, they would say, hey, graduates of this program, 80% have gone on to work at Fang. And so it just felt like, even if it was implicitly said, it was strongly, very strongly implied that if you code, you will make a lot of money and you will set yourself up for success. The reason that people feel lied to, I think, is because kids who otherwise would have gone to maybe study something else, something that they're even more interested in, perhaps, like biology, chemistry, whatever, switched from that, from maybe even a STEM degree to this CS thing because they thought of it as more pragmatic or practical or something that had less risk, lower variance of outcome because it was just such a surefire thing, right? And now, ironically, it's these big companies that are laying off a lot of people because they overhired and they're switching over to using AI tools that a lot of people see as replacing junior and entry level roles. So there's this paradox there where it was the companies that are laying off people now that initially were pumping all this money into campaigns and even lobbying efforts to get folks to start coding more and to make that part of the school curricula. I think that that is sort of this like icky feeling that people have with it. And I don't know how much of that can then be translated into active blame for these big companies. But the reality is that AI has sprung up out of almost thin air. Just COVID kind of felt like it came out of nowhere. And for whatever reason, these kids are the unlucky generation that have to be the first to come in to entry level jobs in the wake of these two big things that happened globally. And it makes sense that you would feel lied to. But before we delve further into this, I want to double click, as you like to say, on the point of to what extent is this a CS problem or is this more of a global issue? Because after this daily piece, I actually went in and looked at some of the Federal Reserve data on employment rates. And one thing stood out to me, well, actually, two things stood out to me. The first thing that stood out is yes, like CS graduates do have historically high unemployment rates, but so do physics majors and so do other STEM majors as well. I think it's just been historically almost a given that CS majors historically had the lowest unemployment rates. But it's not as though CS majors now have 10 times the unemployment of physics majors. They
It's like
basically
maybe they were just the exception to the rule.
That's what I'm saying. So they've basically caught up to the norm at this point. And the one thing that stood out to me as well, or the second thing that stood out to me, was that CS majors, while they have a high unemployment rate, they actually have relatively low underemployment rate. So you got to distinguish between these two things. So unemployment is folks that would like to be working that aren't working, that don't have a job. Underemployment is people that do have a job that would like to be working more because they're working part-time or they're working on a contractual basis and they just would love to switch over into a full-time role. And amongst those roles, CS majors actually fare pretty well compared to other majors. So what it looks like to me is that if you are a CS major and you have a job, you're probably working full-time. If you're not, you're most likely unemployed and looking for a job. Whereas, for instance, anthropology majors, they actually have a relatively lower unemployment rate compared to CS majors, but they have almost like a 40 or 50% underemployment rate. So while a lot of them might be working, half of them would like to be working more because they're only working maybe, say, 10, 20 hours a week. And they're looking to add more hours or add a second job.
Well, you know what they say about CS students, Richard?
What
They
do
love
say?
their binary.
That's true. That's true. Yeah, it's true. That was a good one. I don't know if you prepared that, dude. That was
No,
insane.
that was off the dome.
That was off the cuff. Incredible, dude. So look, I mean, I think there's a lot of nuance here, fundamentally. I think there are weird things happening in the labor market because of AI, because of COVID, because of global trade policies. And it's really hard to put a causal link on AI came about and this has caused unemployment rate in CS. Like that narrative isn't, I think, as clear cut as you would initially think it should be. I do struggle a little bit with the thought that it is on big tech companies to make good on their promise and hire these students. I think that there is a lot of nuance there, and I don't know to what extent the New York Times criticism is valid. How do you see it? Do you think that big companies here sort of underrepresented or oversold the dream of CS?
I mean, I think in a way, right? I think CS can really be broken down into two things, and it was different people who were advocating for them. There was one group of people that was advocating for the workforce of the future, which are the people that say, hey, we really need to train up our domestic STEM population, right? And that's a very practical concern. That's like this region of the economy is growing. There are going to be a lot of jobs there. There's a lot of need for these jobs. We want to fill those jobs. I think the other group of people were a little bit more philosophical, where they were like, well, the skills of computer science, this is like the more romantic side of things, where they were like, well, the skills of CS will help you do better in life, will help you critically problem solve, such that even if you don't end up doing CS, it's good that you know CS. I think I fall a little bit more into probably that latter camp when I think of education policy, right? Like, I think learning math is useful, even if you're not going to be a mathematician. I think learning CS is useful, even if you're not going to be a computer scientist or work in engineering, because what is computer science if not just critical problem solving? And I think that the more that you can do that or systematize your thinking, that is useful across the board, even for other things, which incidentally why is I think a lot of CS people end up making pretty good founders and pretty good product people. It's because they just have these skills of how do you break down very complicated markets and problems into more of a computational paradigm, and then bit by bit solve that problem. I wouldn't be surprised if those are related phenomenon. So to the question of whether or not universities or these companies were lying to these kids, I think what I just saw was actually under training for a long time that ended up getting jobs that in any other sector of the economy would have been impossible to get apples to apples with that same level of experience, right? For a while, these coding boot camps were really big, where basically the idea was you would take a series of courses, maybe in person, maybe remote, for a month or like 2 months. And at the end of that, they would place you with some companies that they worked with, and you would basically be skilled up to be a junior engineer. So they would teach you very practical skills, like how do you spin up a database and how do you build a front end, and use these frameworks that make that pretty easy. Like in the latter years was probably like Next.js. And they'd be like, this is how you can get like a POC, like a working thing. And then this is how you can interview prep. So
I love Next, dude. No hate to Next.
No,
here.
absolutely no hate to Next. We're Next fans on the show. But, I think Next obscures a lot of what's going on behind the scenes, which is great when you really know what's going on behind the scenes, because you're like, oh my God, Next is so powerful because all of this that I don't want to do, Next is just taking care of. If you don't know what that it's actually doing, you don't really know why it's that much better than the alternatives. But anyway, I think some of these were really good. I think they were well-meaning. I think people ended up learning a lot from them. I think a lot of other ones, honestly, ended up just being these conveyor belts where people learned exactly. It's kind of like teaching to the test. They knew exactly what they would have to do to get this well-paying engineering job. And that always, I got to say, put a pretty sour taste in my mouth where, you've gotten these jobs and that's good. But, if the fundamentals aren't there, it feels like you might have passed this test and someone else who didn't get to study for the test in the same kind of way, but knows more about how to build software, didn't get the job because they're just worse at the process. So I guess what I would say is, as part of the exception to the rule of STEM majors maybe have had a historically higher unemployment rate than CS majors, it feels to me that all of this was a slight blip on the historical radar, where for a while, CS jobs were just disproportionately overpaying people. And you see that now with some of the ML jobs that are listed too, where if you really have this super in-demand skill set, and if the labor market has not caught up yet and provided those people, of course companies are going to pay above an average salary, maybe even incredibly high above an average salary. But it did always seem a little bit weird to me that a starting junior engineer's salary would be like 180 at some of these
Yeah.
companies, and a super senior has been in the industry, has seen it all, is only making like 300, 350. Was just always weird to me. It was like, obviously one is going to be more productive than the other. So then I think that maybe can get in the conversation of, well, why did companies invest in junior people at the start? And I think the answer to that in the pre-AI world was, and also I think it's still true in the post-AI world, but you really wanted those junior people to become senior people eventually. The idea
Mhm.
was the industry was absorbing this cost of upskilling junior people who are not as effective, because the senior people are so effective that we need to still keep this evolution going. And the best way to do that was to hire a bunch of juniors.
Fascinating. I think that's right. And I think in addition to paying high salaries, they were also trying to strongly convince engineers that working at this company was the end goal. Once you reach Google, you can stay at Google for the rest of your life. And they were selling this vision of almost how Ford would sell their vision in the 1930s and 1940s, that once you go work at this company, you can stay there for 40 years and retire comfortably. Google, I think, was selling a very similar vision in 2010, 2015 of a world in which you come out of college, you make 180K at Google, and they give you lunches, they give you dinners, they subsidize even your housing potentially. Your life is comfortable. You will not want for anything ever. And that work and lifestyle breeds I guess they want to breed almost like this like fealty or this duty that engineers feel to stay at this company for a long time because they were providers of this lifestyle. And you maybe start as a junior and you stay there for a while and then you become a senior and then a principal and you really enmesh yourself in this massive code base and you get to really know how the company works. And this was, I think, a theory or a hypothesis that Google had for how to build a good work culture and a good workforce in general, was that we wanted to basically get people in this pipeline where they are smart, they come here when they're 21, 22, and stay for the rest of their lives, basically. And the interesting thing, I think, is that while they were trying to do that, all these other companies in Silicon Valley were trying to do the exact same thing. And ironically, what ended up happening was that people wouldn't stay at companies for a long time because they would quickly jump ship to other companies like Facebook, Snapchat, Dropbox, whatever, that would want to do the same Google sort of style hiring approach, but would then always offer just a little bit more money and a little bit more money and a little bit extra perks. And they would just be basically, rather than racing to the bottom, they'd be racing to like an infinite salary where always these companies would be trying to just upscale each other and uplevel each other just a little bit. And it was like this bubble that I think formed, frankly, where companies were all trying to have the same model of a workforce. And it led to these outrageous salaries for a long time that inevitably set up a bubble that would burst in 2020, 2021 when we had these layoffs. And I think the reason that people would blame these companies a little bit is for not being aware of this bubble, for not introspecting a little bit and saying, guys, this is a little ridiculous. To a certain extent, I think people were flagging this because they would be posting these outrageous videos of getting like manicures at Snapchat in LA and working 3 hours a day. And people were somewhat aware of just like the blatant wastefulness of the money that these companies were spending on their employees for things that are ridiculous perks, right? It was like a little bit of a running gag or running joke in the community. But these companies, I think, were aware of it and still decided to keep spending more money in this way and sell this vision that this would inevitably always continue into the future. And high schoolers were seeing this and saying, oh, well, great. In 8 years, when I graduate from college, I'll also be able to do this. But it's so obviously not scalable and not, you can't fund this lifestyle into perpetuity. And so that's why I think people are a little bit bitter at these companies for just like being so short-sighted, I suppose, in this vision, and that clearly we don't live in a world where people are going to stay at a company for 40 years if you give them enough perks and benefits. I see that, and it is like this weird thing that I think we'll study in the future as I imagine this will be like an anthropology course in 100 years, how we were able to build this lifestyle bubble, this lifestyle creep amongst companies like Google and Meta. It's weird,
Financed
man.
by cheap capital in the public markets and the venture capital in the private ones.
And the people that suffered fundamentally, or one group that suffered, are these high schoolers that were sold these false promises. So I think they are like a little to blame insofar as companies made really bad business decisions. But where do we go from here fundamentally? Now that we have AI tools and they just keep getting better. I mean, we saw Claude 4.5 drop on Monday of this week. Do you think that we should be more worried? Is there a bull and a bear case to be made? If you were now basically going to college, would you study CS given the fact that the trend looks like it's trending more in the current direction of AI tools getting better and being better at replacing jobs that have some economic value, like accounting and all the things we covered last Tuesday when we were talking about this new OpenAI benchmark, this GDP val benchmark, where we're showing that these models are actually able to replace jobs very
Yeah.
successfully at this point.
Yeah. I mean, I almost wonder if this won't become like what MBAs did or what happened to MBA programs, where I think one of them ran some regression a while ago saying, given the average case of going to an MBA program, getting an MBA, how does that affect future earning potential versus just not getting an MBA and working those years? And they basically showed that only the top 5 programs, I think, had positive ROI where it makes sense to go to those business schools. It's a little bit of a tough statistical calculus to run, right? Because you almost have to normalize for how talented were the people that got into these MBA programs. Because if the top 5 programs are able to admit the top 5 type of people,
Right.
then yeah, they're probably going to have outsized earning potential because they're just more qualified applicants from the get go. I think they controlled for some of that, but I think like the controlling is hard to do. The picture that it paints, though, is when you go to an MBA program, you're basically getting connections and some knowledge. And if you do the long tail and it's maybe only the knowledge from a different program, that might actually not be that valuable to you at the end of the day. I wouldn't be shocked if we see that happening to STEM programs a little bit more as well, where, yes, it's always going to make sense to go to MIT or to Caltech. But other programs that are just teaching you these like tactical CS skills to try to go out and get a job within this really technical field, maybe will fall the way of the MBA a little bit. We're like, yeah, there are obviously a lot of MBA programs that are not those top 5 that are able to fill classes year over year. But I do feel like there's collectively increasingly an understanding among people who otherwise would get an MBA of, is this even really worth it? Especially if I have to pay for this versus my employer paying for it because they require an MBA to do VP level work or something. Does it really make sense to spend
Right.
2 years in this MBA program if it's not going to give me outsized earning potential? And I wouldn't be surprised if we do start to see that and CS departments begin to be really hard hit, much like you see in some of the humanities, where there are some programs that still are super worth it, still attract a really competitive applicant pool, but a lot more of them have themselves failed this promise that they had once of, if you come here, if you build it, they will come. If you learn it,
Yeah.
you will get a job. And if that no longer becomes the case, then yeah, I think it's super fair, both like what you were saying, for people that have these degrees now to be pretty pissed. But in the future, I think that's going to trickle down too. Like if you're in high school and you're looking at these programs and you say, you know what, the graduates of this one specific university are not really getting jobs, then I don't imagine they're going to be really interested in joining that university as freshmen. And then suddenly you have empty space of classes that can't actually fill those departments. And then I think you're going to see some spiraling to the bottom. I think specifically to what you were asking about, if I were in high school, would I still study CS? I think the answer is yes, in part because you do see some green shoots of companies like Cloudflare, I think just announced their upcoming internship program, which is incidentally trying to hire 1,111 interns on the dot, which is like,
Oh,
this
that's
joke.
cute.
Yeah, it's like
Yeah.
this reference to them as like a central DNS provider being 1.1.1.1. I think Shopify is also trying to recruit talent. And to me, that's really smart because whether you have AI or not, I think a fact pattern remains that you need to have senior staff engineers doing something, coordinating these systems, sanity checking what the AI is able to do by itself. And if you don't have a constant pipeline of people that are coming up and rising the ranks, eventually you're just going to have people aging out of these professions. And I think much like the Cobalt devs who are still employed by these Wall Street firms that have some Cobalt systems. It's like there's got to be some 23-year-old there learning Cobalt, because if
Right.
they do, they're going to be able to get a 2 mil salary in a couple
Oh my
years
god,
when all of these other
that poor
people
person.
have
Yeah.
that poor 25-year-old.
Ugh.
But there's still a market for it. I think that is where maybe right now we're seeing an overcorrection in the market where people are very enthusiastic about augmenting or replacing or like backfilling open recs via AI instead of more junior talent. But I think eventually the labor market is going to have to swing into more of an equilibrium with just the simple recognition of you need junior people to become senior people eventually. I think my recommendation in high school, honestly, would be if you do really love CS, try to do some of it in a non-academic context. Build some side projects, fall in love with the craft for at least in as much as you can for craft's sake, because it can let you do
Mm.
such cool. And I think that like is becoming well known for the new generation of people that are doing these things with no code, low code tools. They're like, oh my God, the power that computer
Yeah.
science could give you. I still do think there's an argument for learning that in a more formal way in high school. But I think it's tough. I mean, I think it's tough, especially if you have already paid for a college curriculum in this, and now you just can't find a job when you're actually in the wild.
You saying that CS is a craft made me think of this like shower thought that I've had for a while, which is that what if CS in the future becomes more artisanal, like the way that cooking or baking or woodworking is an artisanal craft? Because it seems like now that we have these no code, low code solutions where you can go on Replit, Lovable, whatever, you can just create something from scratch. Everyone has the primitive of coding at this point. Like it's not that hard to have an idea and just create code. In the same way that we all have access to a kitchen and we can all cook something. But here's the thing, we're not all chefs, right? Just in the way that everyone
You
has
can
access to
bake a
Replit.
mean apple pie though, brother.
There we go. Yeah. But frankly, it is approaching this world in which the primitive of coding is something that's universal, but the craft of taking this primitive and creating something special with it is something that is still a skill that people can hone and develop. And I could see there being a world in the future in which there are companies that say, "Hey, look, we're competing in this marketplace of all these companies that are doing the same thing. And sure, admittedly, we're doing the same thing as them, but with us, you have the promise that we employ real humans and not just agents that create our code base. And if you have a feature, if you have a feature request, you know, our code is written by humans that really think deeply about the code and try to hyper optimize it for this specific use case." In other words, there can be companies that are producing mass products that are pumping out code, that are pumping out the slop, basically, millions of lines of like redundant code that solve some task. And there can be other companies that are saying, hey, we'll build this bespoke artisanal code base almost that is tightly controlled by the best senior devs. And we have engineers that we hire straight out of college that we train internally to write this beautiful proprietary code that only we can do. I think that humans kinda like that. I think frankly that even though coming back to the baking example, like, even though we can easily buy a loaf of bread from Safeway for $1, we prefer to buy a $10 loaf from the artisanal shop down the street where the head chef is French trained and was at the French Laundry and has a special touch for how to make this thing special. I can see there being a world in which coding becomes more of a job. In other words, where to be good, you have to be an apprentice and you like go through an apprenticeship process where you study with a master coder and you learn the ins and outs of how to use these low code and no code solutions to enhance and augment your own skill set and not to automate it. And that is a future I think that I would personally be sort of excited to live in. That doesn't sound so bad to me, but it does require a little bit of a mental reframe and a big pivot, I think, in how we think about coding nowadays, because so much of it is frankly just quantity over quality. Like in a lot of models, when we analyze these coding agents, we see that a lot of the tokens that are used are just redundant and sort of superfluous chain of thought tokens. And a lot of code that is produced by these models are redundant lines of code. And it feels like we are living in a world where quantity is king, where just the quantity of lines of code produced is more important than the quality. And I hope that that script flips at some point where we go back to like the almost like the artisanal nature of code. Kind of like what we
Mhm.
learn almost in college, where a lot of the assignments are write code that runs in O of n, where the naive version would run in O of n squared. Like a lot of the way we learned CS was through that lens, right?
Yeah, it was like simplicity is the ultimate sophistication. Like the fewer lines of code that you write are absolutely better. You said so many interesting things there that I feel like could be entire podcast episodes. A few that honestly I'll just flag in case we want to come back to them in the future. One, I think, is this irony of where humans can be almost most useful right now when you're in it, when you're trying to interact with some coding agent or you're trying to integrate them into your workflow, is on more of this code reviewer side of things. So like the code's already written and you're saying, hey, I'm actually aware that there's this class in our existing system that does something similar. This logic should probably be encapsulated into that class, or maybe this class even just does that thing and this is unnecessary code. Or hey, you have an error with this thing, or you should refactor this really long sequence. Like all of the stuff that we normally do in code reviews, it's super possible for you just to treat these AI agents as another contributor to a project and then code review them just like you would code review another human being. The irony with that, I feel like, is that is usually the least favorite part of any professional engineer's job. Like people hate giving code reviews and
Right.
it's no fun. It's usually up to the manager because they have to. It's in the job description, or you just give it like a token looks good to me, LGTM. Like people really don't want to spend their time doing code reviews, and people really do like spending their time deep entrenched within writing the code. And I think part of that is because you can get into a flow state, like a creative flow state when you're writing code and you're expressing these ideas in a way that I certainly find pretty difficult when you're in a code review to get in that flow state. You don't really have the same kind of context. It's very choppy. You usually get interrupted halfway through. So I think that that is one tension that if in fact these models continue to be adopted at scale is going to result in us having a pretty big paradigm shift within CS as a whole, or like the institutional practice of doing computer science, where we're just gonna have to really learn how to love code reviews, man. That's the only option.
Here's the other thing coming back to the incentive structures that we build. It feels like when you're at a big company, the easiest way to track progress is to say, how many PRs have you closed? How many commits have you written? How many lines of code have you actually written? And no one is really tracking how many lines of code have you read, have you reviewed. It's hard to say that that is your contribution. Because frankly, the contribution is the person who wrote the code gets the reward of saying, I contributed this. It's
Yeah.
not the person who reviewed who gets to add that to their list of accolades. And so again, it's like this world in which quantity is king. Like the number of lines that you push out is rewarded oftentimes at these companies because you can say, hey, look, as compared to Tommy over there, I did another 30 extra lines of code. So I'm clearly 30 lines more productive than him. And that's messed up because maybe those are bad lines of code. Maybe it would have been way more efficient for you to not write those lines of code. So
Yeah.
it's a lot, yeah. It's just an incentive structure.
Totally. And I think the incentive structure is even more manifest in these big companies right now that are really trying to push AI agents. I think Coinbase was one of these, where they just really want more engineers to use AI models. And I think if I had to kind of read into the psychology, they might be pushing them so hard because engineers just really don't want to use them. So they're trying to overcorrect in the direction of, hey, at least give these things a try. Because until you use them, you don't really know what they'll actually be good and be bad at. But the metric that they're using is lines of code written by an AI in their overall code base. So they're trying to set some number in the ground and say 50% of the code that we have shipped is written by AI, which if you think about it is just a horrible metric because it lets you cheat that so easily by just taking a really short function that you've written and say, hey, LLM, blow this up to be 100 lines. And that actually is very easy for an LLM to do because you're not
Oh
really
yeah.
injecting any more information into the system. You're just saying, okay, let me take something that I already know works and refactor that to be a lot more verbose. So it's pretty easy, which makes it a very hackable metric. Like in RL terms, that would be a very bad reward function for a model because it's penalizing behavior that we actually want, which is sparsity. And it's rewarding behavior that we really don't want in most CS projects, which is lines of code.
And I do think that the more code you write, the more bugs you can introduce easily. If I think about some of the primitive functions, those are typically the shortest lines of code in a code base. And it's almost often when you expand out code into unnecessary extra lines that you introduce bugs through a bad conditional statement, for instance, right? There has to be a way of rewarding brevity in some way in both the, as you were saying, the RL policy and also the organizational structure of a company. But
Totally.
it's hard, man. If you were a high schooler now, I don't know if I would study CS, to be honest with you. In hindsight, I think that I was always someone who was interested in puzzles and interested in figuring out ways of creating interesting things. To me, it feels like the primitives of the future, the things that we are going to study in the future, will always be reliant on some notion of like math or statistics. Like so many of the big breakthroughs in ML or AI have been because people realize, hey, this thing that's been really obvious in the field of linear algebra or statistics actually makes a lot of sense right now for AI. So I don't know if the right primitive to think about problem solving at this point is through code or is through something even more low level like math or
Mhm.
statistics. I'm saying this because I really don't know. Like I would be really hard pressed as a student to have to pick one or the other. Maybe
I mean,
maybe
I
the
feel like some of these universities now are trying to switch to other concentrations in CS, like data science, or just require other kind of classes. Almost like we had SimSys, right? Which was like
right.
a major that itself was a composite of CS and linguistics and maybe even social studies or social sciences made into one, rolled up into one net new major. Do you feel like that's maybe part of the solution is just expanding the scope of what we think of as a conventional CS program to just include a lot of different things?
Yeah, I think so. I think that could be cool. I think the apprenticeship could be cool. Like maybe part of what you do is you go work at a company for a year and then you come back and you take a bunch of non CS related classes to really round out your education. Like a really good education, I think, would be to go work at Meta for 2 years and then spend a year doing just hard math and a year doing like philosophy. Like that sounds like a pretty good education to me. You know what I mean? Like what is an education fundamentally? Like we could have a whole 5 hour long conversation about
Yeah, I
this.
think we could have a whole podcast series about that.
Yeah, how do you
I
measure
also don't know if
what
I'm the best person to weigh in on that.
it's really hard to say, man. I mean, a lot of the majors that were popping up when we were in school were frankly like sort of made up. Like I studied MS&E for my undergrad. That's totally a made up thing. It's like you can basically pick either econ or poli sci or physics or math or computer science or stats, and then you graduate with an MS&E degree, which is what I did, which is like what I
Mm,
enjoyed. And then I switched to CS for the masters, but I don't think it was a bad education. Let's put it that way. I think in hindsight, I actually do enjoy having had the opportunity to go deeper on like stats than I think other CS students did, or take more econ classes. Like I think it does round you out nicely as a student. But I don't know, man. I think it's hard to be a student right now. I think it genuinely is. It's not easy going into your freshman year in 2025. I wouldn't really know what to do as a student right now, other than just explore stuff and probably try to build my own projects and then see what kind of like naturally bubbles to the surface as my core interests. Other than that, I don't know if there's like good advice to give.
I think that's probably the best you can do, Doc. I'd say maybe explore non-conventional paths might be part of that too, where yeah, a vocational school, or even if you've done a lot with CS, I've heard of companies, including very high-flying ones like OpenAI and Anthropic, just hiring kids right out of high school. You know, like they have some really interesting open source project where they went deep on one really critical component, and then these companies pick them up for that expertise and also just for their ability to learn on the fly. I do think that there are other routes even to the same place without having to go the conventional path. And I think at least giving those some thought, spending some tokens, actually thinking through the chain of thought to think, okay, is this the right fit for me? What do I do? What do I want to do? What am I good at? that fusion of things, I think, are areas that we don't really give enough time in high school to do, or like maybe to think about, when people are so worried about what are the extracurriculars that I could really put on my resume so that I can apply and get into a college. I think that sometimes that actually comes at the expense of a little bit of thinking of what do I care about?
I feel like we've had a couple episodes now where we've given this like life advice. And I just want to say we're like in no means qualified to do so. But I,
Talk to your high school counselor. I think is probably
yeah,
the
totally.
right
I was gonna
answer.
say. But it's I mean, I think the reason that we talk about this so much is because it's like one of these big problems that I don't envy any kid to be going through right now. It is like a new thing that's popped up in the last 2 years. And just even like thinking about it and thinking through it brings up interesting questions that are going to be a challenge even for us like in the next 5-10 years. What is our role as like now like mid-level engineers, and like how do we, when we're hiring someone, what sorts of things are we looking for? There's all these, it's not just students who this impacts everyone basically at a company fundamentally. And when we have kids, what are we going to tell them? It's like real like existential stuff here, man.
Yeah,
But that's
it's
what the pre-trained pod's for.
that's exactly right. We don't give ourselves an easy remit, but we do it anyway.
That's right. That's right.
Richard, any closing thoughts? I feel like that's a pretty good place to wrap.
I think that's a great place to wrap, man. Yeah. You're looking ever more bright and angelic with your
You could tell the sun's starting to come out in San Francisco.
the sun's really starting to come out. Yeah, incredible, dude. Meanwhile, here it's just like dark and wintry and depressing.
Well, before I fade to white, I will let you go.
Incredible, man. Well, have a great weekend, Bus, and I'll talk to you on Tuesday.
You too, man. See you Tuesday.
All righty.
Bye.
See ya. Bye.